This is the Prusa Core One, and this is the MMU3 on the Prusa Core One. If you want to print with multiple colors but without endless print time and mountains of waste, then this combination is especially interesting for you. Up to 5 colors, twice as fast and only half the waste of other systems. I have tested the MMU3 for over 50 hours and the Core One itself has been in constant use for over 3 months. In this video, I will show you where the MMU really shines and where it's annoying, and whether the combo with the Core One is really worth it. So you will know exactly whether this will be your next printer or if you're better off choosing another model. In my Core One release video, I was generally positive, but the printer somehow didn't seem quite finished yet. Besides the camera that wasn't available at the time and the filter for the enclosure, it was mainly the lack of multicolor printing capability compared to the competition that I saw as a major drawback. Yet Prusa had already a solution in their lineup since 2023 with the multi-material upgrade version 3, which was in theory compatible, but practically not so much. Now the wait is over, the MMU3 is officially available for the Core One, and of course I wondered, how does Prusa's solution stack up against the competition? The MMU3 is unlike anything else on the market. Only when you understand how it works, does it become clear why the MMU3 has an unbeatable advantage. A typical multicolor system like the Bambu Lab AMS consists of a box where the filaments are stored. Each filament is unwound from the spool by a small motor and fed into the main motor at the output of the box. This then pushes the filament through a PTFE tube to the printhead. The printhead also grips the filament and feeds it into the nozzle. With the Prusa MMU3, there's no filament box out of the box. Instead, the filament sits on the rollers. Each filament is fed through its own PTFE tube to the MMU3, which sits directly on top of the printer. Only there is a motor that pulls the currently loaded filament from the spool and pushes it to the next extruder. Why Prusa chose this design becomes clear when we look at what happens during a filament change. With Bambu Lab and many other printers, the last piece of loaded filament is simply cut off. So the motor in the AMS can pull the filament back the entire way. Using the respective spool motor, the filament is then wound back onto the spool. But this has 2 major disadvantages. First, it takes time for the filament to be pulled back all the way to the AMS. And second, there's now a remnant of old filament in the hot end that first needs to be flushed out by pushing in the new filament. The result is this poop, which you're certainly familiar with if you have a 3D printer with AMS. Prusa takes a completely different approach here. The difference is that with the MMU, the filament isn't cut, but instead the roughly 40 centimeters between printhead and MMU is pulled back. Not only is this faster, but after the change, only a small amount of new filament needs to be pushed through the nozzle. But if that's the whole secret of the MMU for reducing waste, why don't other manufacturers just do the same? The problem is that when completely pulling the filament out of the nozzle, it normally creates a thicker tip with a thin filament string. This could get caught in the PTFE tube during pullback and cause problems when reloading the filament. Prusa came up with an ingenious choreography where the filament is slightly cooled before unloading and moved back and forth in the nozzle. Overall, this is much faster than the AMS change. From the new filament, only a small amount needs to be printed into the purge tower before the actual print can continue. But this also makes it clear that the MMU3 is a technically very complex solution, as the entire tip forming process must be optimally adjusted for it to work reliably. To be honest, I had my doubts, so I came up with a real stress test. The model is the Robo Alpaca, which I turned into a nightmare for any filament changer using the painting function in PrusaSlicer. By distributing all colors across the entire surface, the MMU has to change filaments multiple times in almost every layer. During the print time of nearly 24 hours, over 1,500 times in total. I only used 4 instead the possible 5 colors, so I could also print with a system like the Bambu Lab AMS for comparison. As you can see, it just worked. I didn't have to intervene once. The whole process was just as easy as printing with a single color. And this purge tower weighing 225 grams is all the waste that was produced. And even though that sounds like a lot compared to the 55 gram the model weighs, it's much less than printers like the Bambu Lab X1C or any other multicolor printer with just one nozzle. Because instead of the Prusa's 24 hours, these not only take almost twice as long for the same print, but, and this is really crazy, produce more than 500 grams of filament waste. That's easily more than double than the MMU3. This test is certainly extreme and perhaps a bit unrealistic, but it impressively shows how much better the MMU3 concept is from a technical perspective. But of course, that's only one aspect of a good product. And to answer the question of whether the Core One with the MMU3 is the new multicolor king, let's now have a look at how the MMU3 performs in everyday use. And I did notice some points that I don't want to keep from you and that you absolutely must consider before buying. The most obvious point is the whole filament storage. Since there's no closed box like with the AMS, you need plenty of space to set up the filament spools next to the printer. Sure, this also has the advantage that you can use any type of filament spool with the MMU, including cardboard spools or these 2 kilogram monsters. However, the compact dimensions compared to the print volume were a major advantage of the Core One, which is negated by this. Since the filament can't be actively wound back onto the spools, this buffer must additionally be attached to the side of the printer. At least it can be easily removed thanks to the magnets, so the original spool holder also remains usable. For example, if you want to print filaments like TPU. At least, Prusa has also released the community version of the MMU3 for free and for self-printing on printables. This is basically an enclosure attachment where you lose the ability to use large spools, but you need significantly less floor space. Alternatively, of course, you can just connect one or more filament dryers like this one, because then not only is everything neatly stored, but you can also dry the filaments and almost have a kind of AMS. What unfortunately doesn't get better with this is the whole filament loading process. You first have to push the filament manually through the PTFE tube to the buffer. There you remove the guide roller, replace the filament spool on the holder, pull on the filament end and push it through the second PTFE tube into the MMU3. There the filament is gripped by the motor, and from here everything thankfully goes automatically. Basically no problem, but if you just often change filament, it's just annoying and not nearly as convenient as the AMS and similar systems. When ordering a new MMU3, you have the choice between 3 different variants. A light version without cover for self-assembly, as well as the enclosed version with cover for self-assembly or fully assembled. My recommendation clearly goes to the last variant, and that's for 2 reasons. First, the light version makes no sense to me, because the enclosed build space is one of the essential features of the Core One, especially if you occasionally print technical filaments. And second, the pre-assembled version easily saves you 6 to 10 hours of build time. I wanted to get the MMU up and running quickly and was really frustrated by the endless number of steps. Don't get me wrong, everything is very well documented in typical Prusa fashion, and despite the sometimes very rough appearance of the parts printed by Prusa, it's definitely doable. But the effort is simply disproportionate to the extra cost, so the additional money for the assembled version is well spent. But if you think with the assembled version you just need to screw the MMU3 to the printer and off you go, here comes a big disappointment and one of the biggest disadvantages of the MMU system. Because even with the assembled version you have to swap the so-called main plate of the extruder. This main plate ensures that the filament is correctly guided into the extruder. Especially during filament changes, it's heavily stressed, which is why Prusa includes a variant made from a more robust material with the MMU3. For installation, however, you have to remove the extruder gearbox, and after swapping the main plate, you need to insert the extruder gear wheels through an O-ring into the main plate. Unfortunately, it can easily happen that you push the ring out of its seat and it then wraps around the gears of the inside. It's not without reason that the 2 O-rings are included in the package, and that's exactly what happened to me during my first overtired assembly. Unfortunately, Prusa recommends inspecting and possibly replacing the main plate every 30,000 changes. What sounds like a lot isn't that much, because the limit would be reached after just 20 such alpacas. When it comes to the ease of use, this is one of the biggest disadvantages for the MMU3 for me. Prusa needs to understand that there are people out there who just want to use the printer without constantly tinkering with it. Sure, it's all not difficult and definitely doable, but there are other systems where this isn't necessary. I wasn't aware of this point before buying the MMU3, and unfortunately this topic is rarely addressed in other reviews. Write me in the comments whether you think the criticism at this point is completely exaggerated or if you agree with me. And while we are on the subject of criticism of the design, the solution with the cover hood for a hefty surcharge doesn't seem appropriate to the quality of the Core One for me. The ventilation slots from the original cover plate were adopted, but because of the PTFE tube at the back, there's permanently a much larger opening there, so I really wonder if it makes a difference when I close the ventilation slots. At least the optional fan on the back is powerful enough so that no unpleasant odors escape when printing ABS. And one last point about the hardware that you absolutely need to know before buying. The MMU3 works more efficiently with a standard nozzle than with a high-flow nozzle that comes standard with the Core One. Forming the tip when unloading with a high-flow nozzle is much more complicated due to the 4 fine channels inside. Therefore, my test prints takes about an hour and a half longer. Additionally, more material must be flushed into the purge tower, so its weight increases from 224 grams to almost 400 grams. Prusa therefore includes a standard brass nozzle with the MMU3 upgrade kit, but you lose then the ability in the PrusaSlicer to set layer heights greater than 0.2 mm for fast prototyping. And that's the perfect transition to the software, because the fact that PrusaSlicer has been capable of multicolor printing for quite some time is evident in its operation. Coloring models works excellently, and I think it's really cool that this is even possible via the Prusa app with Easy Print. However, what's not at all progressive is the fact that PrusaSlicer, despite being connected to Prusa Connect, has no idea which filaments are currently loaded in my printer. So I have PETG and ASA loaded on my Core One, for example. It's not enough then to simply change the default filament to ASA in the slicer, slice it and send it to the printer via Prusa Connect. Even though the printer knows that ASA is loaded in slot 5, it would instead print with the filament in slot 1 of the MMU, which in my case is PETG. It does indeed warn me before starting that I have the wrong filament loaded, but that means I have to first remember where which filament is loaded and then explicitly select the correct extruder for this object. Despite the warning that appears again, it then prints with the correct filament in position 5. Why so complicated, Prusa? If I started the print not via Prusa Connect but directly on the printer, I can assign the individual filaments in the print job to my loaded filaments. And such a selection should be available when printing via Prusa Connect, exactly as we are used to from other manufacturers. But is this a deal breaker? For some people, certainly, and that's really a shame. Because after more than 3 months now, and with the MMU3, I'm happier than ever with my Core One. Prusa has shown that they continue to improve their products even years later. The problem with the vertical fine artifacts that some Core Ones have was commented on by Joseph Prusa himself on Reddit, and they are currently working and optimizing the tensioning process for the drive belts. But continuous work is also being done on the soft factors like usability. The camera for the Core One is finally available and now also has features like live streaming over the local network on board. The optional filter solution for the Core One is simply great, because it's not only powerful, but also intelligently and adaptively integrated into the printer's control system. I even made a separate video about slicing with EasyPrint in the Prusa app, because I think this feature is completely underestimated by many. And of course, devices like the Bambu Lab H2D can print with up to 25 colors, even though they play in almost the same price range as a fully equipped Core One. But for Prusa, it's more important to make multicolor printing as energy and resource efficient as possible and to give you complete freedom in choosing your filaments. So if you can live with the maximum of 5 different filaments, as well as the disadvantages I mentioned, then the Core One with the MMU3 is one of the best and most reliable solutions on the market. If you frequently print with many different filaments within one print, you can quickly save many kilograms of filament. Price is another story, and I don't think Prusa can or wants to win the battle with manufacturers from Asia. In return, they offer this repairability, customizability, openness, and European manufacturing for all those who can and want to afford it. I also really like that Prusa clearly communicates that the next version of the MMU will be a new concept and you won't be able to upgrade from the MMU3. But that's still a long way off, and now I'm curious what you think about the Core One with MMU3. Let me know in the comments and also check out this video here.